In the last episode, we fixed the obvious problem. The database schema, jobs are being processed, the system works, but look closely at how it works. If the worker crashes, I restart it. If I want more workers, I scale manually. If logs scatter, I dig through containers. The system depends on me being awake 24 by 7. That's not a scaling problem. That's an operations problem. And that's the pain Kubernetes actually solves. Today, we are not adding features, we are removing babysitting. If this kind of problem feels familiar, subscribe. This series is about earning Kubernetes, not jumping to it because it's trendy. Let's continue. Before diving into the demo, I would like to talk what Kubernetes is. It's not magic. It does not fix bad code. It does not design systems for you. It does not replace thinking. What Kubernetes does is very specific. You describe what should exist, and Kubernetes keeps trying to make reality match description. That's it. Today, we will use Kubernetes only for that, nothing more. All right, let's jump into the Visual Studio Code. I'm going to clear my screen. In here, we are going to create a cluster using kind. I'm going to press enter. Using the command kind create cluster name is job system. Press enter. This is a local cluster using kind. It's not production, but it behaves like production Kubernetes locally. Same scheduler, same pod lifecycle, same restart behavior. If something works here, it will behave the same way later. All right, my cluster is ready now. I can run simple command to check the cluster information. Press enter. So I can see control plane is running, code DNS is running. Now we are going to create another directory called K8s. So on the root level, I would like to create this K8s. And in this directory, I would like to create some files. So let me jump there real quick. And I will say touch api.yaml followed by I would like to create API service.yaml file, and then I want worker deployment.yaml. Press enter. Now we have three different files in here. I am keeping Kubernetes configuration separate. This is from our episode 1. Application code and infrastructure code should not be mixed casually. This separation becomes critical later. Now we are going to create a namespace called job system once again. Namespaces are not optional. They are not for large teams only. They are how you avoid accidental collisions. Every serious Kubernetes setups start here. Now, the first step here is, let's say, to build our API image. I would like to build this. For that, I am using docker build command. Press enter. Once this is success, I would like to build one more image. For that, I'm using once again docker build command using worker colon latest. Press enter. Now we have two images ready. If you are new to my channel, please subscribe. And if you are new to Docker, please go and watch my 2 hours full series which I created. You will learn a lot about Docker. Each and every single line I tried to explain in that video. Alright, let's continue. Now, I would like to load Docker images into our cluster. For that, I am going to run this simple command kind load docker image API latest into our cluster. Same code, no changes. Kubernetes should not force you to rewrite your application. API image got loaded successfully. Now we are going to do the same for worker image, followed by let it run in the background. Now I'm going to jump back to our K8s folder. In here, I'm going to write some code and explain you in a moment. This is a very simple deployment. A deployment describes a desired state. I am saying I want one API pod to exist. If it crashes, Kubernetes replaces it. I am not telling Kubernetes how to restart it. I am telling it what must be true. That's the shift. Now, let's write some code in API service.yaml file as well. So if you look here, pods are ephemeral. Services give them a stable identity. The service doesn't care which pod is running. It only cares about labels. This is how Kubernetes decouples traffic from containers. Now we are ready with our API deployment.yaml file. API service.yaml file as well. Now let's run a simple command. Now we are going to apply this using the simple command kubectl apply file name. That's it. Deployment created successfully. Followed by, I will say kubectl apply service.yaml. Press enter. Service got created successfully. Now let's try to run this command kubectl get pods -n job system. Press enter. If you see, API is in crash loop back off state. Now let's look at the logs. For that, I'm running kubectl logs app is equal to API and the namespace. Press enter. Wow. Look at this error. This error matters because the API is running, Kubernetes started the container, but it can't reach Redis. Inside Docker Compose, Redis existed automatically. If you see here, it existed automatically. Inside Kubernetes, nothing exists unless you declare it. Kubernetes didn't break our application, it exposed a hidden assumption. This is not a Node.js bug and it is not a Redis bug. This is a service discovery problem. Now, let's correct that real quick. For that, I am going to create another file named Redis deployment.yaml. In this file, I'm going to write some code as usual, followed by we are going to create another file named Redis service.yaml. Once again, we have kind service, Redis, namespace job system, app is Redis. And in here, the same replica, we have one application, Redis, container image is, let's say, Redis once again. Now, let's do kubectl apply -f to both the files, followed by kubectl apply -f redis service.yaml. All right, we see another error. Let me go here and try to save this file. I try to forget to save files. This is normal in our day-to-day working environment. Press enter. Now we see service Redis created successfully. Now let's do a rollout restart. Deployment API. Press enter. Restarted successfully. Followed by, I would like to run get pods command and see the status of what's going on. If you see, previously we had crash loop backoff. Now that is getting terminated and we have API service running. Also, if you see, Redis is running successfully. Redis is a stateless. If it crashes, we don't care. If it restarts, we don't care. That makes it a perfect Kubernetes workload. This is how real systems are split. Stateless systems inside Kubernetes, stateful systems managed separately. Now, Let's delete something. For example, I would like to delete pod app API namespace job system. Press enter, and then once again we are going to delete another pod called worker. Let's see what will happen. It is taking some time to delete here. All right, deleted successfully. Now I would like to run this command kubectl delete pod worker. Press enter. No resources found. Expected. Because our worker deployment.yaml file is empty. Now we are trying to create a name worker. Same namespace would be job system. Kind is, let's say, deployment here. Followed by, we are using the image container worker latest, which we built in the beginning. Now, let's try to run this command once again. kubectl apply worker deployment.yaml. Then followed by, I would like to run kubectl get pods job system. API is running, Redis is running, worker is running. Looks good so far. Now let's try to test it end to end and see what will happen. For that, I'm going to run kubectl port forwarding service API 3000 port. Press enter. We have port forwarding in place. Now I will run the simple command which we did in our first episode using curl localhost job k8's user email. Press enter. Same code, same Redis host name. The difference is now explicit infrastructure. Kubernetes didn't fix our application. It fixed our assumptions. Now, let's try to delete pod once again. App worker, enter. It will try to delete. We tried deleting pod and the pod got deleted successfully. Once again, I will say kubectl get pods -n job system. Press enter. If you see, worker is still in place. I deleted the worker. I didn't restart it. Kubernetes noticed the gap and fixed it by itself. Let me use scaling here. kubectl scale deployment worker replicas 3 and the namespace job system. Press enter. Scaled successfully. Now if I run kubectl get pods -n job system, press enter. If you see, we have 3 workers in place. Scaling is no longer copy paste, it's declarative. 3 workers should exist. Kubernetes makes it true. Also, if you want, you can do it in our YAML file as well. You can change it here directly, but I wanted to show you command line as well. Kubernetes didn't make this system smarter. It made it less fragile. I still own the code. I still own the database, but I no longer babysit containers. That's the real win. In the next episode, we will make it worse. Health checks that lie, crash loops, auto scaling disasters. Kubernetes doesn't prevent bad decisions, it amplifies them. See you in episode 3.